So, welcome to our seemingly second day of course, and this will bear on GNG, which is Geology and Geophysics, Production Engineering in Petroleum Engineering, and Flow Assurance. Um, so, we will cover a lot of different area, a lot of different fields. Here about three fields. So let's talking GNG. Let's talk about petroleum system components. In order to have uh, an oil field or a gas field, you need different parameters. First, you need a source rock or the kitchen in a way, where the cooking of the oil happens, and where the oil is generated per se from kerogen to oil. Then there is a migration route. So we show you a card of the world with migration, but basically the oil has to, over geological times and sometimes faster, has to migrate from the source rock to a rock that is a good storage place for it. So as an illustration, we took a dam. So it's a rock that usually has good properties like porosity and permeability in order to store oil or gas. And finally, this is not sufficient. You also need a trap. So a trap rock, for example, that is sealing the 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 reservoir at the top, or it can be other where stratigraphic or structural sort of traps that will keep uh, the oil or gas within the reservoir rock. So to explain that in more detail, the rock is cooked in the kitchen, generated in this source rock, migrating. It can be a rather long migrating route through faults, so through all sorts of unconformities in geology, and then it migrates to the oil reservoir that is represented by this green area. Oil migrates upwards because of buoyancy over time, either drop by drop or slug by slug, through a carrier bed. And the carrier bed is illustrated with this green line by the migration route. And finally, in this oil reservoir, it is stopped by a seal on the top. For example, here it's what we call an anticline. It's a seal that will prevent the oil from fleeing away from this reservoir rock. This takes time, long time, and it often happens at the scale of geological times. So this source system, they generate hydrocarbons of increasing maturity. So it can be heavy oil, light oil, gas condensate, dry gas, depending on the depth and the increasing temperature with depth. So as the temperature increase, we move from to an increasing API. API is a function that is reverse of the density. So the more the temperature, the higher density we reach. So we move from top to bottom, from heavy oil to light oil to gas condensate to dry gas.